again, just finishing this off, the positive 1 and negative 1 cancel with each other. So I've got negative 1/2 times a negative 2x. 1/2 times 2 is 1. Negative times a negative is positive. So that just leaves me x. So this was a rather interesting case in that we have f composed with g of x equals x, and g composed with f of x equals x. So that might have some special significance. Example 6, create a function. Create two functions f and g such that f composed with g of x equals h of x, and this is what h of x equals. So h of x is going to take something to the 50th power. So this part right here, the x squared plus 1, must be my input, and I squared. So the input, so this has got to equal f of g of x. This g of x is what's going to get raised to the 50th power. So I'm going to say f of x equals, takes your input and raises it to the 50th power. So g of x has to be what I want in here. So in this case, I want that to be x squared plus 1. So if that is put into this function, we would take all of this and raise it to the 50th power. So those must be an f and a g that would give me the h of x I want. Okay, let's do another one. Again, I want to find f and g such that f composed with g, so that means g is what you're doing first, equals h of x, and this is what I want h of x to equal. So looking at this, again, I want h of x to look like 3 over some input here squared. Okay, so that's got to equal f composed with g of x. So g of x has got to be what gives me this little piece here. So I don't need an equal sign. So g of x must equal x minus 5. So then I want to take that x minus 5, square it, and divide 3 by it. So f of x is going to take your input, square it, and divide by 3, or 3 divided by that. So this x minus 5 is going to be put into f. So wherever there's an x, I'm going to be putting x minus 5 and dividing 3 by it. And that would give me my composition function.